So I told you that estrogen was feeding back negatively to follicle-stimulating hormone and luteinizing hormone and kind of keeping the levels low. Well, estrogen reaches this point where it actually has an effect on gonadotropin-releasing hormone. The estrogen level gets so high that it causes a surge in gonadotropin-releasing hormone. So you get this little burst before ovulation as a result of these really high estrogen levels. Now, that little burst of gonadotropin-releasing hormone is going to cause, and look, my drawing is, like, I have to back this thing up because, hello, but it's got to be the perfect color. This has to be backed up, like, to here. How's that? Why did I back it up? Because guess what the little surge is going to cause? It causes a huge surge of luteinizing hormone. Like, that thing's a gigantic burst in luteinizing hormone. And it causes a small surge in follicle-stimulating hormone. And here's the scoop. The surge of luteinizing hormone, when that happens, it is guaranteed within 12 to 24 hours of that surge, ovulation is going to happen. What is ovulation? Well, fancy that you ask that question. Let me tell you what ovulation is. Basically, the mature follicle explodes. The fluid filled up so much, it's like a popping zit. It's like this, like it gets bigger and bigger and bigger, and then all of a sudden it explodes. And I'm going to show you what comes out of my exploding, popping. It's a little disturbing sounding, but it's not really that disturbing. My secondary oocyte comes out. My secondary oocyte is surrounded by a structure called the pellucidum, zona pellucidum. Zona pellucidum? Pellucida. Zona pellucida. I thought that sounded weird. Zona pellucida. And the zona pellucida is actually around the outside of my oocyte, not at the primordial follicle stage, but by the time it's a mature follicle, it definitely has a zona pellucida surrounding it. The zona pellucida is like kind of this thick, clear glycoprotein covering, and it's sort of protective, like it's going to keep the spermies out, really, but except for one lucky guy. In addition to this, some of the granulosa cells, not all of them, but look at these surrounding, immediately surrounding the oocyte, they come along too, and this is called the corona radiata. So zona pellucida, corona radiata surround the secondary oocyte, and that's what gets exploded out. Now, it explodes out of the ovary into the peritoneal cavity where fallopian tubes, the uterine tubes, have little fimbriae and little cilia on their fimbriae, and they're literally creating waves in the fluid in the peritoneal cavity, and those waves create currents that pull the secondary oocyte with all of its stuff that's coming with it. It's like a blankie. It's like the secondary oocyte gets to bring its blankie along. Corona radiata is its blankie with zona pellucida as its, like, jammies. And now it's in the fallopian tubes. This is crazy. In the fallopian tubes, it's going to stay in the fallopian tubes for almost 5 days. Like, it takes almost 5 days for this guy to bounce down to the uterus. Now, I just told you that it takes 5 days to bounce down to the uterus, but now I'm going to tell you that my secondary oocyte is only going to live for 12 to 24 hours. That's a sad story. All that for a cell that's only going to live for 12 to 24 hours? What? All right. Well, we definitely need to keep track of the fact that the whole point of this entire thing was ovulating this guy and now creating an environment that's friendly to sperm because this guy's only going to live for 24 hours. So the sperm better get there fast or else they're going to miss their chance at fertilizing this egg. But now we have to shift gears and talk about we don't have a mature follicle anymore, for one thing. What do we have? Well, we have somebody that's going to start producing hormones that, the next hormone that we're going to talk about, which is progesterone. So when my mature follicle explodes, so that the egg is out there, it's now, the secondary oocyte is out there. Well, the follicle turns into this giant, like, blobular, and yes, blobular, no, it's not. That blobular is not a word. Turns into this blobular, okay, glandular. That's what it is. A glandular structure made up of granulosa cells and thecal cells, which can produce what? It's called the, corpus luteum. Corpus luteum. And here's the scoop. Corpus luteum cells aren't either of these kinds of cells. They change. It shifts slightly. And in fact, we change the hormones that we can now produce. Guess who we're going to make? Look at the list.